let's continue. Next speaker is from JA Solar. We have with us Andrew Zhang, who's the technical sales manager with over 9 years in the solar industry. And Andrew will talk about JA Solar's DeepBlue 3.0 technology, also based on 182 millimeter wafers. And he will tell us why JA believes it's the premium solution to lower LCOEs. Andrew, the floor is yours.
Hi, Michael. Wait a moment, let me share my screen at first. Can you see my screen?
Yeah, it looks well. Thanks.
Okay. Hello, everyone. I will say good morning, good afternoon, and good evening. And my name is Andrew. I'm from JA Solar technical team. And thanks for the opportunity provided by the TaiyangNews. And today I would like to brief some key points regarding the JA Solar DeepBlue 3.0 product series and your premier solution for LCOE. And the main focusing of this webinar actually is to give a better understanding about the products after wafer module size in large and technical technology upgrade. And so I will separate my presentation into 3 parts. First one is briefly introduce about the JA Solar and JA DeepBlue 3.0 products design idea. And my proposal is to let the client understand the changes that the PV module are undergoing. So we will analyze how we launch a DeepBlue 3.0 from practical point of view. And the second part, we will briefly introduce the detailed highlights of JA DeepBlue 3.0. And in the third part, we will set up the value analysis of JA DeepBlue 3.0 from the perspective of balance of system savings, LCOE benefits, and actual site survey data. And first, let me briefly introduce about JA Solar. And JA is the top 3 solar module supplier who is set up since 2005 May, and we have around 10% market share. And this is achieved by the JA advanced leading technology and the vertical integrated business model. JA is not only supplying the module, we also have the wafer cell manufacturers globally. And we have the 22,000 employees, and also our annual module manufacturing capacity is more than 25 gigawatt based on 12 global manufacturing. And as rich sales revenue actually and customer confidence, JA has supplied lots of the solar projects, accompanying with recent years global solar projects rapid rise. And here are some utility projects in Asia Pacific regions, which JA has supplied our high quality and stable products for this project taking off. And of course, besides the utility, JA also supplies some solar module for floating project, which is a very interesting topic in global market. And here's some floating projects. And besides floating and the utility, so we also have the CNI projects globally. And here are some typical projects. And okay, so let's start with the first part regarding the design idea of DeepBlue 3.0. And first, we need to go back to the module technology development since 2009, and it will be good starting from the module power increment history. And this graphic has shown the module what is increment within the 10 years. And from this blue part between 2009 until 2020, actually you can obtain the information that the module power increment is contributed by cell efficiency increasing annually, and integrated technology such as the PERC, PERC SE, half cell, and multi-bus bar. And 10 years ago, so the module power is only 290 wattage, with the module efficiency only 17%. But after 10 years, the module power has achieved to 400 plus, and with the module efficiency more than 21% more or less. But actually, the biggest changes is started from the year of 2020, and because the low PPA incentive as a module supplier point of view, and J has launched a couple of kinds of the products for meeting the market request. And this is details so how the module power has been enhanced by different technology. And the first item is regarding the cell efficiency climbing up from the 17% to 23% during 2009 to 2020. And this is mainly contributed by the PERC technology boosts up the cell efficiency and compared with the previous poly technology. And in the meanwhile, raw material has been fully optimized. I think this is shared by previous speakers. Some of the good quality and high technology raw material has been conducted, such as the anti-reflection coating and the secret extra soft ribbon, and high transmittance EVA, and other like workmanship, half cell, multi-bus bar, and this technology and workmanship also enhance the module power increment. And besides, actually, the wafer sizing is enlarged from the 125 meters to 156 meters, usually we call M2, and then go to 166 millimeters, which we call M6, and then now goes to M10 or G12. M10 is 182 millimeters, and the G12 is 210 millimeters. And so based on various wafer sizing of the module, and actually we can make the comparison based on the balance of system perspective. And from the graphic on the left, and we can obtain the information that based on same solar module efficiency, and the larger module with higher power output will significantly reduce the BOS costs. But however, based on these 2 yellow point, the trade-off BOS deduction effects becomes less when keep enlarging module sizing. If you compare, let's say, this one is 78 cells 182 millimeters module, and 66 cells 210 millimeters module. Though the 210 millimeter module power bin is higher, but it doesn't make the efforts for BOS savings. So apart from the power bins, so we also grab the BOS savings from the efficiency point of view. And we also obtain the graphic on the left as well. And significantly, so efficiency contributes more than BOS cost reduction compared with wafer sizing. And the large module size has reached its bottleneck based on the current industry status. And the module efficiency increment will be considered as a priority. So the module power bins and efficiency is not considered. So we also need to consider the other factors. So we need to consider the module application practically, and whether the module is the larger, the better. So firstly is, I think this is shared by TUV right inside, and this larger module can maintain the mechanical property. So when the module is delivered to the project site, so whether the workers can easily hand over and install smoothly, and because the larger, the heavier. And in the meanwhile, so whether the current structure can could be compatible with this large module, especially in a high wind load region. And from a technical point of view, and these factors need to be verified by actual project deployment. So let's put the previous concerns aside, and actually I would like to simply evolve one small subject regarding the modules VOC and ISC, which will be considered as priority. And we all know that actually power equals voltage and current, and the higher powers means high voltage or high current. If voltage drop, the current will be increased significantly. And low voltage can add the string capacity and decrease the system cost, but impact from the large current on system, the module itself should be noted. And this is another simple summary for 182 millimeters half cell module and 210 millimeters half cell module. And you can see from the left graphic that actually more busbar technology will improve the power bins. And I think currently most of the module supplier has upgraded to 9 busbar and to 12 busbar. But of course, more resistive loss will be involved if deployed more busbar. And this lead higher module CTM loss, which we call the cell-to-cell mismatch loss, and the module production cost. And in the meanwhile, during module operation period, high current will also lead higher module itself resist loss and boost up the module operation temperature. So which may lead potential issues, which we know such as hotspots, junction box delta burnout. And so for clarify this high module operation temperature stuff, so JAR&D has set up the test bed for this comparison between 182 millimeters module and the large current module, and the real data was collected based on one intraday solar system during operation period. And obviously, so we can see this graphic, and the solar module temperature become higher if the module is larger current, and this lead significantly reduce loss and power generating loss. And the recording actually from the third party as well. So compared with large current module, actually the power generation of DeepBlue 3.0 module is more than 1.5% higher. And of course, the LCOE is significantly better. So we can reach a conclusion that actually pursuing low voltage and high current not being recommended, and module property should be matched with solar system configuration. It's very like structure and inverter. And module design should be determined not only balance of system savings, but also LCOE. So for verifying the actual data, so Jay also cooperated with TUV Node, conducting 1 year. I think so far is around 3 months. Outdoor solar project monitoring plan at National PV Experimental Center in Yinchuan, northern west of China. And during the high irradiance period, the average module operation temperature gap between 182 meters module and the larger current module is about 1.7 centigrade. And the maximum temperature gap is up to 5 centigrade. And consider cold weather in February and March of Yinchuan location because it's in the western of China, and the actual working temperature gap should be larger in summer. So we also record the data at project site, and the power generation of 182 module per watt is about 1.7% higher than larger current module. So this is a design principle for 182 meters module, which is based on the suitable dimension. As you know, that this is less than 2.3 meters long and around 1.134 meters wide. And this dimension is easily for handover and has the proper electrical parameters with around 50 voltage and 13 amperes. And in the way, we also J182 meters DeepBlue 3.0 also consider optimized container loading quantity and easily for transportation and system capability. So for part two, let's go is focusing on the technical highlights of DeepBlue 3.0. So currently, JA are proposing 3 types of 182 meters module for different market segments. And first one, we have the 54 cells module with probably around 400 more or less for residential and commercial market, and the 72 modules with a power being 540, 545, mainly using for utility solar farm. And I just confirmed with our product team. So for this SNEC, our first launch product will be 78 modules. So the power is targeting around at 585 to 590. And as vertical business company, so JA currently has a metro production facilities for 182 millimeters module mass production and metro supply chain for fulfilling global projects demand. So for JA DeepBlue 3.0, it deploys with support technology, and then is under 182 millimeters cell, and we at JA is the gallium doping holder. So this wafer is integrated with the gallium doping, and it is half cell, and it is 11 busbar. And actually, before selling to our customers, actually JA had already passed all kinds of reliability and tests and the third party. And first of all is some details for the wafer and the cell side. And JA had deployed the second generation PERC technology, and usually we call PERC SE, and with better long spectral response and a higher low irradiance property. And in the meanwhile, it also has low temperature coffee efficiency. And the new substructure of cell module will enhance around 2 to 3% power generation during operation period. And the gallium doping with IP rice will make less degradation during module surface life. And for single glass module, the first year is 2% and 0.55% from year 2 to year 25. And for double glass module, which we call double glass bifacial, so the first year degradation is 2% and 0.45% from year 2 to year 30. And 11 busbar pattern, also this design also extremely shorten current transmission distance and lower resistance loss, and also reduce the risk of the cracks and the finger broken during module production. And square ribbons are replaced by the round ribbons, improving optical utilization and module power. And both technology are supporting module durability and temperature and the load fluctuation, especially thermal cycling and dynamic load power loss. And the 182 millimeters module is designed for half cell for sure, and instead of the full cell. And this will lower the internal resistance loss, module temperature during operation, and less shadow impact and the stress of mechanical property. And it also has the ultra excellent circuit design, reduce module current mismatch loss, and the temperature is 10 to 20 centigrade lower, especially in the hotspot situation compared with the full cell module. So here we would like to share a summary of the DeepBlue 3.0 solar module benefits. Currently, this type of module are available to order already, and with annual production capacity around 20 gigawatt in 2021. And it has the lower temperature core efficiency around minus 0.35% per centigrade, and high efficiency low light condition response, and excellent degradation, and monofacial and bifacial. So this is the power distribution. So we are focusing for 72 cells, 182 millimeters module, and 78 cells, 182 millimeters within 2021 and 2022. So in the last part, actually, I would like to present DeepBlue 3.0 from cost analysis point of view. And I think most of the APC and customer are concerned about the costing. And I would like to share the cost from different perspectives. And the first one is suppose that the solar project is designed based on the fixed angle structure, which is most common solution for molten system globally. And this is data from the third-party EPC company, and we can see that 182 millimeters module with 72 cells and 78 cells, structure cost plus cabling plus foundation cost will be lower or same as 210 millimeters module. And from single SX tracker, so we also evaluate 182 millimeters module based on single SX tracker, and according to the evaluation, which is listed by the top 3 tracker supplier. And deploying with 182 million module will save the structural cost up to 40%. And from LCOE perspective, we're different sizing of module because we are putting different kinds of the sizing of the wafer together. And compared with the 158 million module with a power of 415 and 166 million module with a power of 450, and the DeepBlue 3.0 has LCOE deduction. And based on the 545 wattage, 182 DeepBlue 3.0 and 590 78 cells DeepBlue 3.0, and this is actually the expect LCOE deduction will be around 5 to 7%. And based on the larger sizing of the module, LCOE perspective, and we also set up the simulation based on the project in Dubai, and where we can see that this computation is based on 182 78 cells module, and then 210 50 cells, 210 60 cells. The sizing of the project capability is around 30 megawatt, and we can see that actually 182 million modules still have the LC benefit, so which could will be more benefit for the achieving the lowest LC target for project taking off. So okay, so product launch in a SNEC. As JA Solar is a very practical company, so actually for different market we have different kind of the solution providing to the customer and end user. So like 182. So currently we have 2 kinds of products: DeepBlue 3.0, 54 cells module. So for residential and commercial, and the rooftop is not very strong. And for utility and the commercial, we also have the 540 wattage module. And in SNEC, so we will launch the 78 cells module as the first product, which is based on the 182. And I think you can join the first day of SNEC. So Jay will launch another 2 product with some metro technology. So sorry for the confidential, so I cannot explore during this webinar. So if you have any questions, so you can feel free to contact me. Hello, Michael.
Thanks, Andrew.
Yeah,
this very nice overview. So we have a few minutes left, maybe a couple of questions. So I think in the past, actually, you talked also about gapless technology. Are you what kind of technology are you using now to reduce actually the space between the cells?
I think currently there are many kinds of technology, so reducing the space. I think LONGi has introduced, they are using the small distance, and the Jinko is promoting the Taylor ribbon. So actually, from Jay point of view, so we still keep it confidential, but we will launch very soon during the SNEC. So it's one kind of the new technology, but it's mainly used for reduce the distance, to be honest. And in the meanwhile, so besides reducing the space, distance, so for the cell technology, I think many people is talking about HAT, N-type, TOPCon. So we also select one kind of technology where we launch together with this distance workmanship. So this will be integrated together.
So that means we can expect some, whatever it is, N-type technology you will be introducing at SNEC.
Yes, it's N-type, but together with reducing the distance technology together.
Okay. Exciting, exciting. When you talk about how can we improve power further after a 78 cell configuration? What do you see there?
So, okay, so actually from 182 millimeters module manufacturing point of view, actually 72 cells is very fair at best for the projects taking off. And I think currently some of the EPC or customer, they are asking for the higher. So I think 78 cells module is mainly focusing on the customer who is require the higher power bins for their projects taking off. And because another thing I think maybe you know is currently 72 cells 182 meter module is adapted with current inverter configuration. And if upgrade to 78 cells, so for sure that we need to make sure not only the inverter, but also the structure and other balance of system need to be upgraded together. So I think this is how this industry is driving the new product launch.
Okay, I think that's it from my side for the moment. If you could actually also stay with us, because of course we have JA and Longji also later on the panel to discuss further details. But Andrew, if you could stay with us and answer some questions in the chat, that would be very nice.
Yeah, sure. You're welcome, Michael.
Okay, thanks again for your presentation.
Yeah.
Very insightful.